Good morning, students. Today we will learn the relationship between inverse trigonometric ratios functions. Consider one triangle ABC in which angle B equal to 90 degree and sine theta equal to x. So theta will be sine inverse x. Now to derive all these formulas, consider one triangle in which one side BC as x and other side hypotenuse 1. Using Pythagoras theorem, determine base, that is under root 1 minus x square. So this way you consider the sides, because sine theta is x upon 1, x will be perpendicular and 1 will be hypotenuse. Now you determine the base, it will be under root 1 minus x square. Now sine theta is x upon 1, so theta is sine inverse x. Now here you determine value of cos theta. Cos theta is AB upon AC equal to under root 1 minus x square upon 1. It means theta is equal to cos inverse under root 1 minus x square upon 1. So comparing both thetas, you have a relation. You have a relation that sine inverse x is equal to cos inverse under root 1 minus x square. Whenever we need to convert sine inverse x into cos inverse x. Using this formula, we can convert it very easily. In a similar manner, we can also write sine inverse in term of tan inverse x. So how we will write? We know that tan theta equal to perpendicular of BC upon base AB. Perpendicular BC is here x and base is under root 1 minus x square. This way theta value will be tan inverse x upon root 1 minus x square. Comparing both thetas, we have sine inverse x equal to tan inverse x upon under root 1 minus x square. Similarly, we can write sine inverse x in term of what? Sine inverse in term of sec inverse x and sine inverse in term of cosec inverse x. In a similar manner, we can establish the relationship between cos inverse x and other trigonometric ratios. For cos inverse x, you can consider x as a base and 1 as hypotenuse. Using Pythagoras theorem, get the length of BC perpendicular, that is under root 1 minus x square. Now theta is cos inverse x here. Theta is cos inverse x, and then theta will be sine inverse under root 1 minus x square. So comparing both the thetas, we have cos inverse x equal to sine inverse under root 1 minus x square. Similarly, cos inverse x can be written in term of tan, that is tan inverse under root 1 minus x square upon x. Cos inverse x can be written cosec inverse 1 upon root 1 minus x square. Cos inverse x equal to sec inverse 1 upon x. So these are the relationship between cos inverse x and other inverse trigonometric functions. So in a similar manner, there is a relationship between tan inverse x and other inverse trigonometric functions. Tan inverse x can be written sine inverse x upon under root 1 plus x square. Tan inverse x equal to cos inverse 1 upon under root 1 plus x square. Tan inverse x equal to cot inverse 1 upon x. Tan inverse x equal to sec inverse under root 1 plus x square. Tan inverse x equal to cosec inverse under root 1 plus x square upon x. Same way, cot inverse can be written in term of other inverse trigonometric functions, also sec inverse x in term of other inverse trigonometric functions. and cosec inverse x in term of other trigonometric functions as given here. So to derive these formulas you have to draw a triangle. You have to draw a triangle in which take one angle as right angle, other as A, and other third angle as C. So consider any side of triangle according to the given inverse trigonometric function. Suppose we need to convert cosec inverse x in term of other. So cosec is the ratio of hypotenuse and perpendicular. So cosec x consider as hypotenuse and 1 as perpendicular. Using Pythagoras theorem, determine the third side, that is base, and this base will be x square minus 1. And after this, now you change this into other inverse trigonometric ratio. Suppose you need 10. 10 is perpendicular upon base. Perpendicular is 1 and base is under root x square minus 1. So you can convert all the and cosec inverse x in term of all the inverse trigonometric ratios. So students, you try to prove all these formulas to understand this formula better. So now after this, the principal values of negative value of x, here sine inverse minus x, sine inverse minus x equal to minus sine inverse x. Same way cos inverse minus x equal to pi minus cos inverse x, tan inverse minus x equal to minus tan inverse x, cot inverse minus x equal to pi minus cot inverse x, and sec inverse minus x equal to pi minus sec inverse x, cosec inverse minus x equal to minus cosec inverse x. So how we will derive this? You consider sine inverse minus x equal to theta. So minus x equal to sine theta, x equal to minus sine theta. You can write it x equal to sine minus theta, and minus theta equal to sine inverse x means theta equal to minus sine inverse x. Comparing both the thetas, we have a relation sine inverse minus x equal to minus sine inverse x. In a similar manner, second part, cos inverse minus x is equal to theta, minus x is cos theta, x equal to minus cos theta, and x equal to cos pi minus theta. It means pi minus theta is cos inverse x. This means theta is pi minus cos inverse x. Comparing both thetas, we have cos inverse minus x equal to pi minus cos inverse x. So similarly, you can derive other four parts. These parts are very important, and how we will use these in questions. Suppose we are finding the principal value of sec inverse 2. To determine the sec inverse 2, we can write here sec inverse 2 equal to pi minus sec inverse 2, and pi minus sec inverse 2, it means pi minus pi by 3. Sec inverse 2 is at pi by 3. You need to see only in first quadrant now. So simplification, this gives you 2 pi by 3. Automatically it will come in range of the inverse trigonometric function. This way you can try other part, the first part, second part, third part, fourth part, fifth part, sixth part, all negative domain is here. So this will help in all negative domains. Now another relationship, that sine inverse x plus cos inverse x value is pi by 2, tan inverse x plus cot inverse x equal to pi by 2, sec inverse x plus cosec inverse x equal to pi by 2. So to derive this, you consider x equal to sine theta. So theta is sine inverse x. X equal to cos pi by 2 minus theta means cos inverse x equal to pi by 2 minus theta. Transfer theta to the left side. Cos inverse x plus theta equal to pi by 2. This gives you sine inverse x plus cos inverse x equal to pi by 2. So this way you can derive all the all remaining three formulas based on this. Now we are going to prove this identity. Tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy. Similarly, tan inverse x minus tan inverse y equal to tan inverse x minus y upon 1 plus xy. Third, cot inverse x plus cot inverse y equal to cot inverse xy minus 1 upon x plus y, and cot inverse x minus cot inverse y equal to cot inverse xy plus 1 upon y minus x. We know that from trigonometry, tan a plus b equal to tan a plus tan b upon 1 minus tan a tan b. Tan a considered x, tan b y, a equal to tan inverse x, b equal to tan inverse y. Then we get tan in place of a we are putting tan inverse x, b in place of b tan inverse y, and this become x plus y upon 1 minus xy. And transferring this tan to the right, we have a relation here that tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy. Similarly, you can derive other part also. You can use tan a plus b, tan a minus b formula for cot a plus b, and cot a minus b formula of trigonometry. Now, one of the example here to illustrate this result, we have to prove tan inverse 1 upon 2 plus tan inverse 2 upon 11 equal to tan inverse 3 upon 4. Second, first part, tan inverse 2 upon 11 plus tan inverse 7 upon 24 equal to tan inverse half. Tan inverse 1 upon 7 plus tan inverse 1 upon 13 equal to tan inverse 2 upon 9, and the fourth part is also there. So applying the formula, tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy. So in place of x, write 2 upon 11, and in place of y, write 7 upon 24 in the formula. Take LCM, simplify, you will have tan inverse half. Similarly, you can solve other part also. Using trigonometric formulas, you can also derive the relationship between sin inverse x plus sin inverse y, cos inverse x plus cos inverse y, cos inverse x minus cos inverse y, cos inverse x plus cos inverse y, and other formulas also. Those we will see in the next round. You please try all these honestly today and learn the application of all these, and I hope that you will work positively. Thank you and good day.